Hi everyone, this is Dr. Swaminathan SM. Now I am going to take about the topic modeling of electric systems. So first review about the previous class. We discussed about the that is transfer function versus BBO, bounded input and bounded output. Next, the types of systems and dynamic systems, ways to study a system's model and its needs, activity, and modeling of electrical system, that is called RLC, resistor, inductor, capacitor, and the voltage and current relationship. Following with the examples, we will summarize the topics. Static system means if a system does not change with the time, that is called static. If the system change with the time, that is called a dynamic system. So again, the system is dynamic. If the current output that depends on the past history as well as the present input, that is called the dynamic system. So y of t is equal to y of u of tau, that is 0, or tau is between 0 to t. U is nothing but input, t is nothing but time. That is example, moving mass. So F is equal to ma, force is equal to mass into acceleration. So ways to study a system that is experiment the actual system, the modeling of the system divided into two, physical mathematical model, and again the mathematical model divided into simulation based analytical solution. Simulation means frequency, time, and hybrid domain. Model means that is a simplified representation, abstraction of the reality. And again, the reality is generally too complex and exactly it models. Insert the mathematical equations that describes the input-output behavior of the system. And again, what is the model used for? Simulation, prediction, forecasting, prognostic, diagnostic, and the design performance evaluation. That is the control system design. So black box model, that is easy to model when only input and output only known. Interdynamics either too complex or unknown. Gray box model means input output some information about the internal dynamics of the system. That is easier than the white box modeling. So u of t inputs y of u of t comma t, that is equal to y of t. Y of t is the output, u of t is the input. That is gray box modeling. White box modeling means when the input and output and other internal dynamics of the system is known. So one should know complete knowledge about the system to derive the white box modeling. And following with the activity, you need to fill the empty circle. So again, the basic elements, you need to understand the resistor. That is very mainly considered. B.B. Roy, Great Britain, very good wife, we already discussed. Based on the color coding, you must know the resistor values. VR of t is equal to IR of t into R. So V is equal to IR. And Laplace transform, that is VR of S equal to IR of S into R. So time domain is converted into S domain, that is called Laplace transform. So the basic element, the capacitor means if they are given the capacitor, then we need to find the voltage means Vc of t is equal to 1 by C into integral part of IC of t into dt. Again, you substitute the Laplace transform, a t domain is converted into S domain. Next, the same thing for inductor, L into di of t divided by dt. So here Laplace transform applying means L Si of L into S. So these are all the voltage and current relation and current and voltage relation. So resistor means just if you start the upper off, then you need to close the lower off. If you start lower off, then you need to close the upper off. That is a way to draw the resistor. So VI relation, VR of t is equal to IR of t into R, and IR of t is equal to VR of t divided by R. That is V is equal to IR, I is equal to V by R, that's all. And again, capacitor means 1 by C integral part. Again, current means that integral part converted into differential part. Inductor means same thing, VL of t divided by integral L into dI, differentiate part. Again, it is converted means integral part. This is the VI relation and IV relations. So example 1, the two-port network is shown in figure Vi of t, that is V naught of t is output. Again, the transfer function V naught of S divided by Vi of S. So VIFT is right KVL I of t into R plus 1 by C integral part of I of t into dt. That is the input pole. That is the input loop. And again output loop means just to say V naught of t is equal to 1 by C integral part of I of t into dt. Again just to arrange this time domain into S domain means just to substitute the Laplace transform and Vi of S equal to Is of R plus 1 by S 1 by Cs into I of S. Again V naught of S is equal to 1 by S Cs into I of S. So rearrange the both the equation, you can get the V I of S and Cs into V naught of S equal to I of S. So again this Vi of S and Cs, substitute the Is equation in left, then you can get the V naught of S divided by Vi of S. So this is called the V naught of S divided by Vi of S equal to 1 by 1 plus RCS. So the system pole, that is one pole. So 1 plus RCS is equal to 0. So S is equal to minus 1 by RC. So again another example, the system pole at another side S is equal to minus 1 by RC. So minus 1 by RC is equal to minus 3. Then you can get RC C values. R is equal to 1 mega ohm, C is equal to 333 picofarad. Then you can get the values. This is called the another example. Thank you.